Hi there. In this video, I will explain how you can use UFT Developer Grid using a small demo to solve some of the common test execution challenges we often encounter. Here is a quick overview of what the UFT Developer Grid solution architecture looks like. Without the grid, what you will have is basically all your tests are going to execute on a remote machine based on the name or IP. And these tests usually have hard-coded machine names or IPs which are part of the test itself. Some of the tests and some organizations do also one level of abstraction by taking these machine name and IPs into property files, or they kind of put them in Excel sheets. But nevertheless, they are still hard-coded in the property file or a Excel. So it does not solve the purpose of ensuring that dynamically allocating your tests into remote machines. So the challenge with this approach is that your tests are going to run only in the machine in which they are configured. So for example, let's say you have this test and this test is configured to run on this remote machine. Now, if this test fails, if this machine fails for whatever reason it's down, then your test will not be able to execute on this machine, or it will not be rerouted to the next node which has similar capabilities. This is exactly what Grid is able to do. Now with UFT Developer Grid, all your tests basically only define the environment parameters in which you want to execute these tests. And when I say environment, you only say that I want to execute on a machine with a certain OS, a certain browser, or a certain software, for example, Java 11. So take, for example, here, when you're using the grid, you have two components that come into play. You have your grid and then you have your remote nodes. Now in the remote nodes, you basically configure different machine capabilities. So each node will have a unique set of machine capabilities that you have as a part of your node. And what you then do is you register this node in the grid. Once this is done, you can then run all of your tests and pass those tests. Each of the commands from your test scripts will be passed to the grid, and grid ensures that it chooses the right machine in which those capabilities exist, and it executes those scripts in those machines. Let's take a quick example. In this case, you have three nodes. The machine 1, the node 1 has Windows 10, Chrome 89, Java 11, .NET Framework. And in the second node, you can see it's a Linux, Ubuntu, Firefox with Java 8 and Maven. And the third machine is a Mac machine with Safari 14, Java 16, Chrome 85, and a Firefox browser. So you can see there are three browsers here. So this tells you that each of the nodes have different combination of machine capabilities. Now, when you run a test, for example, the first test that you execute, that you pass to the grid, let's say, has the environment details to run on Windows machine. So the test basically passes to the grid, and the grid has dynamically allocates that test to the appropriate machine which has the right capabilities to execute that test. And these environment details is what we define inside the test. So let's say, for example, you define that you want to run in Chrome browser, right? And you execute this test, and the test comes to the grid. Now the grid has two options. It can either send it to this machine where Chrome exists, or it can even send it to this machine where it exists. So let's say one of the machine is down, the grid will then reroute the test execution to the other machine where Chrome browser exists. Let's now see UFT Developer Grid in action in a demo. In here, let me describe the test environment that I have here. What you have here is basically I have one machine. As you can see, it's Ubuntu Docker. This is the machine where I will write my scripts, and I will also configure this as a grid later on. I have another machine, UFT Dev node, and this node is basically the test execution machine, which will be configured as a node later on. I also have third machine, which is also a node machine where the test execution will happen. The difference between the two nodes machines is that on one node machine, you have basically Firefox, and in the second node machine, you have basically Chrome. As you can see, all the three machines are basically Linux machines. In real world, you would ideally have different combinations of OS, browsers, different versions of browsers within the same machine or different machines or in any combination. No, so in our test environment now, you have all three are Linux machines. Like I said, you could have any combinations of OS browsers versions, and other machine capabilities like Java. Let me now take you through the script that I've created in this machine. Here you can see I have basically created a project, AOS parallel test. It's basically a test-ng project. Right within the test-ng project, you can see basically I have test 1, test 2, and so on. I have about 6 tests which I have described or basically written using UFT Developer Test-ng template. Now let's go through one of the tests, and remaining all of the tests follow a similar pattern. In test 1, you can basically see the first section here as I've highlighted. I have basically described the capabilities of the machine, test execution machine, on which this test has to run. I have not configured the exact IP or the machine name where this execution has to happen. So as you can see, I have defined here a browser description object called browser disk, and for this object I have set properties of OS type as Linux and browser type as Chrome. Alternatively, these properties, browser type and OS type, are inbuilt properties that are available with the grid or with the browser description object. But you can also add your own custom properties as well, which you can define in the node and then use them here. Now so to any UFT developer script, you'll basically need to add these additional lines if you are using the grid. As you can see, I have commented few lines. You can alternatively also choose which version of the browser you want to use for your test, and accordingly it will pick up a node which has all those machine properties. Right now you can see basically I have commented the versions, but to kind of give you a simple demonstration of how this works. But in complex environments, real world, you'll ideally have the browser version, the browser type, the browser version, the OS type, the OS version, and you might have other software that is also installed in that particular node. You can define all of those right within here. The rest of the test is basically your standard UFT developer test. But as you can see, the line at which it is launching the browser is when the grid basically locks behind the scenes the entire test environment or the machine for execution. So every time it has to execute the actual steps is when it basically the grid locks the machine for the rest of the execution of your test. So essentially your script still remains in the Ubuntu Docker machine, and the test execution will eventually happen in node 1 machine or node 2 machine, right? So now what we will do is I will show you the test-ng configuration. You can see I have basically defined that I will run all the methods in parallel, and this is basically the class that I am executing, UFT developer test. So this is exactly the test here. So I have similar 6 tests. So this is test 1. I have 6 different tests which are very similar to this, except the only difference you can see here it is Chrome, and in test 2 it is Firefox. In test 3 you will notice that it is Chrome again. It's test 3, it is Chrome. So you can see I have almost 6 tests alternating between Chrome and Firefox that these tests have to execute. So now to kind of set up the um, grid machine, go to your installation folder, which is opt UFT developer bin, and right within here start your leanFT in a grid mode. So as you can see, this is the command in Linux. The approach is the same, but you know the commands could be different in Mac and Windows. So just start your leanFT in where the role is grid. So now when I run this, the Ubuntu Docker machine in which I'm running this will now become a grid. You can see the role is now grid. Similarly, what I will do is I'll switch to node 1, and within node 1, I will now start UFT developer as where the role is node, right? Same command earlier in the Ubuntu Docker machine, the role was grid. These are the execution machines, and so I start leanFT as a node. I run this, quickly validate that it's running as a node. You can see the role is node here. Do the same thing in the other machine. Here, let's start leanFT in the role with role node. So you can see I have all 2 nodes registered to the grid now. To view this, all you got to do is basically launch a browser, and you can see the grid in 8080 port. You can see there are 2 nodes connected, node 1 and node 2, and the grid was able to identify that web add-in is enabled. There could be other environments like mobile or desktop technologies. You can see the browsers that are configured in the nodes. In the node 1 there's Firefox, in the node 2 you have configured Chrome, and the other custom capabilities that you have configured as well. On the right side you can see the actual executed concurrent run. So once you execute the test, it will actually show you how many executions are happening, and you can see all of that in this view. And this view is basically the grid management view. So let's switch over. Now go back to the test. Before that, let me actually show you within the node. Um, I'll change the view now to, I'll go into tools folder, and here we will run the settings lean FT to show you what are the configurations that we have set for the browser. So you can see the node 1 basically has Firefox. You can see here Firefox. So what I've done is I've configured Firefox here, and I'm using the default version. Alternatively, you can actually choose specifically the version that you want. And if you have multiple versions installed on the machine, you can add as many versions here, and then you can define the execution path and profile. For now, we will leave it as default, right? You can also configure multiple browsers if multiple browsers are actually installed on these machines. So let's go ahead, cancel this. This is just to show you what is the configuration you can do on the node and how to register it with the grid machine. Now, once this is done, let's go back and execute this test. And because I've used testng to run all this test in parallel, what you'll notice is that when I execute this test, the 6 tests will be distributed between node 1 and node 2. In the node 1, since we have Firefox, all the Firefox tests get executed here. You can see 3 Firefox browsers overlaying on each other, and they're all executing in parallel. Similarly, in node 2, you can see the tests are executing, 3 tests are executing in Chrome parallelly, right? Chrome is a little faster. You can see Firefox, you can see 3 if you are observing this closely. There are 3 browsers where the tests are running in parallel. So as you can see in this flow, basically we configured a grid machine in Ubuntu Docker in this machine where the test existed. We configured that as with the role of a grid. And when the script ran, each of the test, you had 6 tests, and each test was basically sent to the grid, and the grid decided based on the browser description capabilities that you defined within the test. These browser description capabilities were used by the grid to kind of send it to the appropriate test execution machine for execution. Let's now quickly look at the results. The results basically flow back from the node to the grid or from the machine from where the test was executed. So go to the run results folder. Let's open it in a browser. And here is your complete report. You can see all the 6 tests ran successfully. As you know, these tests basically are invoked in different order in testng. So you can see test 2, there was Firefox, and you can see basically it launched in node 1, right? The test 2 was launched in node 1 because we configured Firefox and Linux. We defined OS type as Linux and type as Firefox. So this is the machine where we wanted machine capabilities we wanted for the test. And basically the grid picked up node 1, which had similar capabilities. Let's take the next test, test 3. You can see here we are basically in the test 3, you have the browser type as Chrome and OS type as Linux. So this time the grid basically chose node 2 as the test execution environment. So this way it was able to execute all the tests parallelly in both the machines. This is pretty much it. Thank you for watching.